In today's class, I'm going to start a new topic, which is on programmable logic controller. Now, next few lectures is going to be on this topic, some basic introduction of the different components that is necessary to construct a PLC or the internal architecture. Then we'll discuss about a common programming method to program this type of device, that is ladder logic programming or ladder diagram programming, and observe a few examples in order to get some initial idea how to use this particular device. Now, first of all, some introduction on PLC. So it was initially developed in the 1969, and during the same time the developments of microprocessor was also done, the initial microprocessors. So the development of the microprocessor actually led to the designing of the PLC. So it is a microprocessor based controller that can be used to design complex control systems, maybe in order to sense or activate or control some industrial system. And their designing is done in such a way, in a robust way, so that they can be easily used in harsh industrial environments. So in the industrial factories, there could be a lot of uh, negative aspects, such as there could be a lot of dust, there could be a lot of vibration or high temperature fluctuations. So the construction is done in such a way so that it can operate smoothly in those harsh environments as well. Now, it is a programmable device. Now, a set of instructions is going to be stored in this device. So the microprocessor is going to execute those instructions and try to implement some operations, some logic operation, or suppose some logic or sequencing, or providing some timing delay to some output, or doing some counting operation or some arithmetic operations. These things is going to be done by the microprocessor, and finally it is going to provide some output signals to the output which is connected to the PLC. So if you are familiar with using microcontrollers or Arduinos, you know that in this sort of devices, the inputs and the outputs are connected to the input ports and the output ports, and based on the program, the relation between the input and output is established. And if it is necessary to modify the uh, relation between the input and output, it can be easily done by changing the program. So for PLC as well, the user is normally given a set of input ports, a set of output ports. So the user is going to connect the inputs and the outputs, and how to manipulate the data uh, uh, that is fetched from the different input ports. That is going to depend on the set of instructions or program given by the operator or the user. Now, PLC is a microprocessor based controller, and I also mentioned about microcontroller, that Arduino or other microcontrollers are there. You are studying a course on microprocessor in this semester. I think a lab is there on my 8086 microprocessor. So I hope that you know the fundamental difference between a microprocessor and a microcontroller. So can anyone suggest? Can anyone suggest what is the difference? Yes.
Microprocessor is used for large purposes and it has a large size, but microcontroller is for small purposes like Arduino or Raspberry Pi boards, and it has some small functionalities compared to microprocessors.
Okay, that is correct in a sense. Anything else you want to mention? In terms of the different components, I mean, okay, it is for large scale, this is for smaller scale applications, but in terms of the, I mean, uh, different units or components required to make the system operable.
Sir,
Yes.
microprocessor, it only processes the data and releases. For microcontroller, it has a storage facility to keep the data inside.
Okay. So some storage came into consideration here. Okay. So in order to store the program that is written by the user, or in order to store the data, you need some memory units as well, in form of RAM or ROM. So in case of microprocessor, the RAM or ROM, these memory units are not integral part of the microprocessor. They has to be externally connected with the microprocessor. Microprocessor has some internal memory in the form of registers, but the RAM, ROM, these things has to be externally connected with the microprocessor, so that it is giving you a complete package. Whereas in case of microcontroller, the RAM, ROM, these things are integrated into a single IC. Whereas the IC of the microcontroller doesn't have RAM, ROM, these things integrated into the single IC. So in case of PLC as well, as a microprocessor is used, in order to make it uh, uh, completely functional, to store the data or to store the user's program or to store the operating system, the RAM, ROM, these things has to be connected externally. Now, the last point which is mentioned over here, that it is designed to be operated by engineers with perhaps a limited knowledge of computers and computing languages. So back then when the PLC was developed, you know that during that time the microprocessor was also just evolving. So programming a microprocessor was a difficult task to do, because that required special skills, because programming in terms of machine language or assembly language, these things were not that much easy to do, programming complex control systems. So to make it easier for the technicians, so that they can easily program the device, the PLCs were uh, manufactured in such a way so that in terms of graphical form, or in terms of ladder circuit diagram, the uh, uh, technicians can easily program this particular device as well. So we'll discuss about ladder logic programming later on. Now, before that, before PLC was used in order to implement different control systems, the task was done by relays. So relays were used in order to implement different control systems. So the how a relay operates, I think you guys have a basic idea, right? I mean, can anyone suggest about relays, how they operate?
Sir, relays work on like we have to relays operates on sensing some current or voltages. So if some current and voltages are sensed, based on that the relay mechanism are initiated, and it connects or disconnects the circuit or do some other purposes.
Okay, so it disconnects or connects, or it makes contact or it disconnects a certain portion of the circuit, makes or breaks contact, right? So normally you are having, say, two input terminals, two output terminals. Are the input and output directly connected with each other?
No, sir.
Okay, so like you said that it senses current, and when it senses current, it either makes a contact or breaks the contact. So it does that in terms of electromagnetic mechanism. So the relays are actually electromechanical devices which operate based on the principle of electromagnetism. So at the, if this is the input side, this is the output side. At the input side, the two input terminals are normally connected with an electromagnetic coil. And the output side is normally having either normally open contact or normally closed contact. So I have here designated a normally open contact in terms of a switch over here. So this is a normally open contact. When this contact at the output side will close when this particular coil is getting energized. And when the coil is going to energize, when there is supposed to be some current flowing through the coil. For example, if we have the input terminals connected with a DC power source and a switch, so if some user or operator presses this switch or closes this switch, then some current is going to flow through the relay coil. So when the relay coil is energized, it will uh, operate this particular contact. So if the contact is initially in normally open state, then when the coil is energized, it will become closed, and whatever the circuitry is connected with the output terminals, it will have a path, it will have a closed path. For example, at the output side, maybe there is a motor which is going to operate on an AC signal, suppose of 240 volts, and on the input side there is a switch, a 5-volt source. So when the switch is going to be closed, the coil is going to energize, the contact is going to be closing as well, the normally open contact will close, and there will be a path of current flowing through this motor, so the motor will start rotating. So one of the purposes of using relays is to provide isolation between input and output. So if an operator was supposed to operate a switch uh, directly, which is connected to the motor with a high voltage source, here I have shown a single phase connection. Maybe there could be 3-phase uh, motors as well. So directly closing or opening a particular contact or switch sometimes may impose danger for the operator. So using relays, some isolation can be provided between the input side and the output side. So at the input side, using a very small voltage level of 5 volts DC voltage, the operator can operate the switch with minimal danger. So uh, when this coil is going to be energized, this contact on the high voltage side is going to be closed and the motor will operate. So one advantage of using the relays is to uh, ensure isolation between input and output and providing safety for the operator. And also from two different sides, you can operate between uh, operate in multiple voltage levels. Now, using these relay logic controllers, uh, multiple logic functions can be established, or an autonomous process can be also designed. For example, here I was talking about a manual switch. So instead of a manual switch, if this switch is replaced by a sensor, so there is no to need for an operator to manually operate this switch. Upon receiving any feedback from the sensor, the relay coil is going to energize, and it can operate the device which is connected at the output side. Now, using multiple contacts or multiple relays, different logic functions can be implemented as well. For example, okay, now here the contacts I have shown you in terms of the normal switching symbols that we normally use to represent a switch. Now, in case of relay, the relay coil is often also uh, represented in terms of a circular symbol. Maybe the circular symbol is representing the coil, and the contacts are represented by two horizontal lines or two lines like this. So this is representing a normally open contact, and this is representing a normally closed contact. So maybe these symbols are familiar to you, or at least to those students who have uh, taken the switchgear course or the power system protection course. Is it? Is there any student who has taken power system protection or switchgear? Okay, so these symbols are also used to represent the contacts. So if I say that I have two different relay contacts like this, suppose contact A and contact B, two different normally open contacts of two different relays. Suppose one is relay A, another is relay B. So this is first relay, this is second relay, and I am using the two normally open contacts of these two relay, and along with that, suppose I'm connecting an output, a motor as an output device. So in this, if we use the two normally open contacts in this fashion, then what sort of logic we are actually implementing using the two relays?
Or
Yes, so simply we are implementing an OR logic, because if any one of the relays are active, the or relays are getting energized, their corresponding contact will close, and there will be a path of current flow for the motor. So in this way, using the relay physical relays, these electromechanical relays, the control systems can be different logic functions or uh, other sequencing or timing operations can be implemented, because there are some relays, timing relays or counting relays, they can provide time delays as well. So implementing the control systems using the physical relays was a challenging task, because uh, I mean, for complex systems or large control systems, large number of relays would be required, and the more the number of relays, the more complexity will arise, because the more hardware wiring has to be done. And if it is necessary to make any modification in a control system that is entirely based on physical relays, then doing that modification will also become a challenging task, because all the hardware connections has to be removed, then they have to be reconnected in order to implement and the modification. So to make the control system process easier, the PLC has some advantages over the relay logic controllers. The first one is that PLCs are programmable. So thus, any change that you want to make or any modification in the control process that you want to make, you can just do the modification in terms of the program. You can make the modification in the computer program rather than changing physical connections between different multiple relays. And as there is no requirement of having large number of physical relays, the dimension of the control system or size of the control system also reduces. Now the relay controllers are some way noisy, because making or breaking of the mechanical contacts make some amount of generate some amount of sound or noise. However, the PLCs, which are based on obviously solid state technology, because uh, uh, instead of using electromechanical relays, solid state devices are used to manufacture the ICs or the transistors that are associated with the PLC. So the PLC also provides noise-free operation. And also the solid state devices provide faster response or faster operation compared to the relay. Now, the special functions such as producing time delays or counting a number of objects, these things can be implemented also easily using the software program rather than implementing them in terms of physical relays. So these are some of the advantages of PLC over the relay logic controllers. Now in terms of a diagram, so a comparison of the size of two control systems, one designed with the relay logic and another designed with the PLC, is shown over here. Okay, so in terms of relay logic control system, you can see that multiple physical relays are necessary, and interconnection between or hardware connection between these relays becomes a challenging task, and also the size of the control system is very large compared to a PLC based control system. So whereas in a PLC based control system, there is only connection between the input devices to the input ports, the output devices to the output ports, and all the other logic operations or delay operations or any control process is actually done in terms of the computer program rather than doing them in terms of physical hardware connections. Now, discussing a little bit on PLC hardwares. So, what are the different components or fundamental functional components necessary to construct a PLC? So, first of all, a microprocessor is going to be needed, as discussed already, that is going to carry out all the controlling tasks. Now, in order to connect some input devices and output devices with this microcontroller, some input interfacing unit should be there and some output interfacing unit should be there, so that data can be read or write in the input or output devices. So in order to write the program, a programming device is necessary, which is basically a computer. And in order to store the data or store the program written by the user, some memory chips are also necessary in form of RAM, ROM, as already discussed. And some communication interface is also necessary. So in order to write the program into the memory unit, Some communication interface is necessary to write the program from the programming device into the memory of the PLC. And also, if it is necessary to establish intercommunication between multiple PLC boards or other autonomous devices, the communications unit interface unit can be used. And obviously there has to be a power supply unit that is going to regulate the input power supply and provide the desired power voltage levels to the different units. Is the microphone okay? So maybe if the microprocessor is designed, or the input output interfacing units are designed to operate at 5 volts, then the job of the power supply unit is going to be regulating the input supply, which might be an AC supply, to regulate the AC supply into the desired 5-volt level, so that the microprocessor and the other units can function properly. Now the working principle, so the input devices, which could be manual switches or sensors, and output devices can be motors, lamps, valves, solenoid valves, etc. So these are going to be connected to the PLC, and the operator enters the sequence of instructions in the form of a computer program, and the controller or microprocessor monitors the inputs and executes the program to give proper output instructions. Now, these things are already discussed, that doing small modifications is very easy to do, just changing the sequence of instructions. Now, let us discuss a little bit about the internal architecture of the PLC. So, in your the lab of microprocessor, maybe you have in the initial classes you have studied about the internal architecture of the 8086 microprocessor. So you have detailed understanding of the CPU or the microprocessor, which is contained in the CPU of the PLC board. Now this particular architecture is representing the entire system of the PLC in terms of the microprocessor, which is associated in the CPU, the other memory devices, the input output units, the input output devices, how they are actually interconnected, and how the operation normally takes place. A general idea can be obtained through the internal architecture. Now, in this particular figure or diagram, you can see there are normally 4 buses. The first one here mentioned is the input output bus, data bus, control bus, address bus. So there are 4 buses. So what do you actually understand by bus in this case? I mean, in electronic circuits or electrical circuits, what do you actually understand by a bus?
Yeah, so
Yes.
yeah, both is their I can say their path where data flow in.
Okay, so paths for data or signal to flow. Maybe in a PCB board, the conductive strips are the paths for the signals to flow. So that may be termed as a bus. So it is actually a path which is providing a connection between multiple devices so that the data can be transferred or the signal can be transferred. Now, which signal is getting transferred, depending upon that, the different buses are named according to their function. So the purpose of the input-output system bus is to transfer the input data or the output data between the input-output units and the input or outputs connected with the PLC. So for example, maybe with the input channels, some input devices are already connected. Now, their signals are passed through the optocoupler to the buffer, then through the buffer through the input-output bus. The signal is going to be going to the input-output unit of the PLC. So from the input channels or input ports, the next particular block here shown is the optocoupler. So what is the function of an optocoupler? Do you guys have an understanding what is an optocoupler?
No, sir.
Optocoupler is actually similar to relays, that it provides isolation between two different parts of the circuit. So from the name, it optically couples two different parts of or two different circuits. So in general, the symbol of the optocoupler can be represented like this. So a optocoupler might have an LED and a phototransistor. So whenever this LED is connected with some uh, input device, maybe a switch or a sensor and some input source, so if there is any current flow through this LED inside the optocoupler, the LED will glow and it will trigger this phototransistor. So if any output device is connected, current will be flowing through the output device as well. Now here the output is basically going to be transferring the signal towards the input output unit. Okay, so but in general an optocoupler works similar to relay, but in terms of, instead of using electromagnetic coil and mechanical contacts, it uses optical devices in the form of, suppose, LED and phototransistors. So there is separation between different uh, circuit different circuits, but the different circuits can be coupled optically using this use of photo LED and phototransistor. The purpose of using the optocoupler is that to ensure some isolation between a particular input device and the entire internal system of the PLC, so that if there is some high transients or fluctuations in the input device, that can be separated from output, separated from uh, the rest of the portion of the PLC, so that if there is some uh, damage due to high voltage fluctuations in a particular input port, only that input port is getting damaged. To protect the entire rest of the system from getting damaged, the optocouplers are associated with each input port to ensure the safety of the operation. And the different input ports, maybe they are operating at different voltage levels, but from the output of the optocoupler towards the internal circuit of the PLC, a fixed voltage is going to be supplied, so that the voltage remains in the stable or proper operating limit of each unit inside the PLC. Buffer is temporary storage devices. Now there could be fluctuations or frequent fluctuations in the input devices or the devices which are connected to the input port. Now, the execution of the CPU or the microprocessors depends on the frequency of the clock. So in order to keep the data stable for some time so that a particular cycle of operation can be completed within one clock pulse, the temporary storage in the form of which are referred here as buffer are used so to temporarily store the data for some time so that a particular clock cycle can be finished or execution cycle can be finished properly. Now from there, using the input output bus, the data is coming to the input output unit. So let's say some input data has been uh, transferred to the input output unit. Now how the CPU actually functions, so uh, the CPU will normally function in maybe three steps. It can be considered to be three steps, that is fetching the data, then decoding the code which is written by the user or instructions which is provided by the user, and then executing the code and providing the necessary uh, 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 I mean providing the necessary operation in terms of writing some data or sending some signal to the output devices. So how the CPU actually does that? So in order to read the data from the input output unit, the CPU is normally going to send some signal through the control bus towards the input output unit. So when the CPU is sending the control signal that the CPU wants to I mean know the data what is in the input output unit, then from here using the data bus the data is going to be transferred towards the CPU. Next, the CPU might want to write this data depending upon the user's program. Maybe the CPU wants to write the data to some memory location. Now, in case of the microprocessors or microcontrollers, you know that each memory location is defined by an unique address. So, if the CPU wants to uh, uh, access a particular memory location, it has to access with the particular address of that particular memory location. So, for example, the data that the CPU has obtained from the input unit, it wants to uh, store the data maybe at 0001 at this memory address. So, what the CPU will do, it will indicate this particular memory location through the address bus, and it will also send a controlling signal through the control bus to the data RAM, and this particular address, which address the CPU wants to write the data, that is going to be designated through the address bus. So the a particular memory location, suppose 0001 of the data RAM is indicated by the address bus, and whether to read or write that data, that is indicated by the control bus. So depending upon that, the data is either stored in the data RAM, or if the CPU wants to read some data, then also the same thing can be done from the data RAM. So which address at which address the CPU, maybe just we can consider that the CPU wants to write some data, so the address is going to be sent through the address bus. The controlling signal, which is to write the data, is going to be coming from the control bus, and the data that is to be written, that it is coming from the data bus. So in this way, through different uh, buses, the CPU sends different signals to different portions of the units. Now similarly for the other units, you can actually uh, in a sense self-explained that how the process should take place. And for some of the uh, units, you can see you have some bidirectional arrowheads, and for some units you have single directional arrowheads. For example, in the system ROM, you can see there is only a outwards arrowhead towards the data bus. So maybe you can suggest why is that? Anyone?
Sir, can you repeat the question?
I'm saying that for most of the other units, you can see there is a bidirectional arrowhead from the unit to the data bus. But for the system ROM, there is only is outwards arrowhead towards the data bus. Why is that?
Sir, it cannot be overwritten.
Yeah, so it cannot be overwritten because what is in the ROM, it is only read-only memory. You know that in ROM, the manufacturer actually install its operating system. So it allows data only to be, uh, I mean, fetched
Read.
from its memory. So that's why it is showing that through the arrowheads, it is indicating that from the ROM, there is no possible way to write any particular data to the ROM. But the CPU can access different functionalities available in the ROM by reading a particular reading the instructions given in the ROM. But for the other memory units, suppose the user program RAM or the data RAM, the CPU has the option to both read or write uh, in those memory locations. And also you can see that the CPU only has the option to send control signals. That is supposed to be the case because the microprocessor is controlling the operation of every other units. It is not supposed to receive any control signal. So it is only sending control signals to other units. So through these outward arrowheads, it is indicating that it is sending a control signal to all the other units, and the other units are only able to receive the control signal. They are not able to send any control signal to the CPU. So in this way, the overall operation of how this fetch, decode, or execute this operation can be takes place within the multiple units that can be briefly understood using the internal architecture. Now, on the output side, if some data has to be transferred to the output ports, that can be also done through the input output unit. So from the input output unit, the data will be transferred to the latches, which are temporary storages, and different types of loads which may require different types of drivers. So through the driver interfacing, later on the data is going to be transferred to the output ports to operate a particular output device. So this is basically the internal architecture of the PLC. Now for today's class, I would like to conclude up to this. Now if you have any question regarding today's class, uh, you can ask the question. After that, I will conclude today's session.
Sir, is it possible to add extra memory devices to PLC so that we can store large number of instructions?
Well, in most of the cases, the PLC come in a way that they have the option to incorporate different modules. For example, you can add extra memory chips, or you can add extra input output ports, or some other extra modules you can add. So in most of the cases, the PLCs are modular designs. So it is possible to add extra memory chips, or also extra input output units as well.
Sir,
Yes.
one PLC that is been compact already and been sent to like a factory or an industry, can it be programmed to control different, let me say, devices, like for example, motor or any other different things, or one PLC could control one device at a time?
No, one PLC can control multiple devices, because there are multiple output ports. So you can connect different types of devices at different ports, and you can control through the instructions that is going to be set during the programming. So it is not that using one PLC you are going to control only a single motor, or you have the option only to control motors, but you can control multiple output devices. Those can be of different nature.
We can use another PLC as output to another PLC, right? I mean, we can control other PLCs using another PLC, right?
You can establish communication between multiple PLCs. There is the option to connect multiple PLCs using Ethernet port. Okay, so maybe between multiple PLCs using the Ethernet ports, you can make connections and make some sort of a local area network. So yes, you can transfer data obtained from one PLC to another PLC. So that can be used to actuate some process in the other PLC. So in that sense, you can influence the operation of one PLC from the data obtained from another one.
Okay, sir.
What's the difference between a microprocessor and PLC?
Well, difference difference is, there is microprocessor is supposed maybe a single chip. To In order to make it properly functional, to implement a control system, you need to associate the memory units, the other input output units. So you can say that PLC is giving you one example where a microprocessor is applied, or one application of the microprocessor. So without the microprocessor, it is actually the brain of the PLC. So the PLC is not nothing without the microprocessor. And by connecting the memory units, the input output interfacing units, you are making the device, uh, you are making a complete device. Okay, so that the user can use it as a controller. Now, even in case of your computer, okay, your computer is having a microprocessor, but the microprocessor alone is not able to give you the allow you to do all the tasks that you're doing, because in your computer as well, you need RAM, ROM, then other peripherals such as input devices as keyboards, mouse, these things has to be connected with the microprocessor one way or another. So microprocessor is the chip that is going to execute all the programs, but in order to have a uh, fully functional system, you have to assign the different units with the microprocessor. So this is one example where a microprocessor is used to create a control system. Okay. The student who asked the question, is it okay for you?
Yes, sir.
Okay, anything else? Anyone? Okay, so let me conclude today's session up to this.